All right, so here we move on to determinants. So there's more work to be done if we're trying to find a determinant of more than a 2 by 2. All right, so first off, there is a checkerboard pattern of positive and negative signs that you need to just have memorized. So this is the positive position, this is the negative position, this is the positive. So anytime you're marching out, you start here positive, positive, negative, positive, negative, positive, negative, positive. So these are the signs that correspond to each of these positions. And it is given by this. So you don't have to have this memorized. You can always just count along to find out where there's positives and negatives. All right, so a cofactor is going to be taking into account the positive and negatives, and then we'll be taking the determinant of the matrix that's left over. So let me illustrate this with an example. It's easier to do that than to give this in subscript form. All right, so here I have a 3 by 3 matrix. So what I'm going to do is I'm going to expand it about the first row. So I'm going to take the determinant about this row. So here is the positive 3. And then this is the negative position. So I'm going to put the negative 0 just for effect. And this is the positive position of 4. All right, so let's look at where this comes from. So once I take 3, I cross out the row and the column that 3 is in, and this is the 2 by 2 matrix that I'm left with. All right, so let me erase this so we can see what's going to go on for the next one. So for 0, so again, this is the negative position. I'm going to cross out the row and the column that 0 is in, and the matrix I have left over is 2, 0, 2, negative 1, and that's what this is. And then let me erase this. So then we move to the next position, 4. So this is positive, negative, positive position 4. And I cross out the row and the column the 4 is in, and this is the 2 by 2 matrix that I'm left with. Now I do know how to find the determinant of a 2 by 2. So this 3 carries along, so I get negative 3, subtract a 10, and then there's 0, and then plus 4, and then I have 10, subtract 0, so there's 10. So I get a negative times, a 3 times a negative 13, and plus 40, so that gives me a determinant of 1. All right. So when we're doing this cofactor expansion with large matrices, you want to pick a wise row, or you can choose a column, doesn't matter, a wise row or column to expand about. So I'm thinking lots of zeros would be nice, wouldn't it? So I'm going to choose this row to expand about. All right, so and this would be the expression with the notation. So this is this position A here, this is A31, and then C is the determinant of the matrix that's left over, and then A32, A33, A34. Okay, and so you can just count through and do the positive, negative, positive, or you can use this notation here. So here I'm going to move down, so positive, negative, positive 2. And that's the same thing as saying negative 1 to the 4th power, which is 3 plus 1. So positive 2, and then I'm going to have the determinant of the matrix that's left over. So 0, 0, 5, 7, 2, negative 5, 3, 1, 8. So I get this. And then it'd be 0 times the others. So I just put them there for effect so you could see them, but they really don't need to be written there. Okay, so now in order to find the determinant of this matrix, I'm going to expand about this row. So keeping this 2 out in the front, right? This 2 right here is this 2 here. So I'm going to have 0, 0, and then finally I have this. So this is positive, negative, positive 5. So I put the zeros in there for effect. So positive 5 times the determinant of the 7, 2, 3, 1 matrix. So this 2 times this 5 gives me a 10, and then when I take the determinant here, I get 7 minus 6, which is a 1. So the determinant is 10. So make sure that when you want to choose a row or a column that gives you the least amount of computation in figuring these out.